Okay, people, here we go. First thing you need to have out is your rules page. Okay, get your rules page out. So we'll start with number 1. Number 1's just a calculator problem. So remember, on your calculator, if you're using this one, you use the caret to raise your power. So 5 power, and then use your negative button right here, negative, and then 1.5, and so the answer is 0.089442719. And then you see it says round to 3 decimal places, so we are D, number 1. Number 2, remember this formula. It says the population in a particular rate growing at a rate of 2.4%. If 10,184,000 people lived there in 1999, how many people will be there in the year 2006? And then we're given f at x is equal to y naught e raised to the 0.024t. So remember that your y naught is your starting point, so that would be your 10,184,000. And then your time, you know, if it says that this was in 1999, so then you have to consider that like the starting time. And so it went from 1999 to 2006, so your time would be 7 years. So all you have to do is substitute those values in. So f at x is going to be equal to 10,184,000 e raised to the 0.024 times 7. I do want you to notice something on this one, because we're going to have to use this formula again a little later. But notice your percent right there. Your rate per year is 2.24. And I want you to notice what's right there multiplied times the t in your power. Okay, so that's important, and we will use that again. So putting this in your calculator, put in your 10,184,000. Okay, and raised to the 0.024 times 7, and you're going to get, oh, I forgot the e, sorry. So 10,184,000, okay, e raised to the 0.024 times 7. And so that's going to give you approximately, remember whenever we have these exponentials and we're using the e, we're not going to always get the exact answer. So we got 12,047,000 some change. So the answer is 12,050,000, round to the nearest 10,000ths, or 10,000, sorry. Okay, next. This one, if you go back and you use the Desmos calculator that I sent you guys, recall that if you had f at x is equal to 2 raised to the x, so that's our exponential. If you look at that, recall what those looked like, go back and think about that, the base. And so the base, remember, it's going to go through that 0, 1, right? And then it's going to kind of hug and curve around and look somewhat like this. And we talked about what happens if that number becomes a fraction between 0 and 1. Well, it took this curve and it reversed it over. That's what a fraction did to it. So our answer would be A. Okay. Next, we go back and we look at f of x is equal to e to the x, go back and look at him. Remember what that base graph looked like, okay? And then what is adding 5 to that x going to do? Remember, it's going to cause that 0.01. It's going to shift to sorry, the left 5. So if we look at all of your answer choices right here, you can see that 0, 1 point. So think about the 0, 1. It's right here, right there. Okay, so that point right here would have to shift 5 to the left. So 1, 2, 3, 4, 5. So I'm looking for the graph that goes through the point right here, and it's going to look the same because nothing else has changed. And so the answer would be A. The answer would be A. You're going to have to go back and remember all these graphs and kind of what they look like. Make yourself a note card. Next, this one is just a basic compound interest formula problem. So all you have to do is figure out what the values are that you need to plug into the formula. Your A, that's your accumulated value. Okay, so you need to know P, R, N, and T. P, R, N, and T. And you should be able to get that from the word problem. So it says find the accumulated value, that's the A, of an investment of $5,000. Your investment, that's the P, at 5%, that's the R. And this compounded monthly, that's the N. Monthly, there's 12 months in a year. And then for 8 years, that's the T. So I get P is 5,000. R is 5%, which is 0.05 decimal form. N, compounded monthly, would mean 12. And T would be 8. So 8 equals 5,000 times 1 plus 0.05 over 12, and raise it to the power of 12 times 8. Okay, so plugging that into my calculator, 5,000 parentheses 1 plus, and then I see a fraction, so I use the fraction button, 0.05 over 12, toggle out, close your parentheses, raise your power, and then 12 times 8, and hit enter. So that's going to be, A is approximately 7452 point. Now this is money, so we would say 0.93. So that correct answer would be D. Okay. Next. So for our next problem, we're going to have to go back and remember some from our rule page, this top line from our rule page, that's going to help us. And so what we need to remember is that if we have a base raised to a power equal to something, then I can write its equivalency in log form, which would be log base B of A, and that would be equal to C. So looking at what we're given, we know that the B is going to be 4, the C is going to be 2, and the A is going to be 16. So just plugging those in, log, the B is 4, the A is 16, and the C is 2. Okay. Now, for some of you, this might be harder to find it. So you might be able to memorize this part better, going from the log back over to the exponential expression. So b to the c is equal to a, b to the c is equal to a, b to the c is equal to a. So if you wanted to, you could come over here and you could say b to the c is equal to a, b to the c is equal to the a. No, that's not it. B to the c is equal to the a, b to the c is equal to the a. Yep, there it is. Okay, so you can work it from that way. Okay, so for our next one, we're going back to our rules page. Don't forget about all these rules. Have it handy. Have them memorized for your test. And remember, if you recall, I said if we had square roots, we needed to use powers instead. And remember, a square root is the same as raising something to the 1/2. Okay? So if we had the square root of x, it would be the same as x to the 1/2. So rewriting this, we have log base 6 of 6 to the 1/2. Log base 6 of 6 to the 1/2. So if we go back and we look at our rule on our page that I gave you guys, rule number 6, it says log base b of b raised to the k. The b sort of like cancel each other out, and you're just left with the k. So we're just going to be left with the power, the k. So the answer is 1/2. No math. You just have to know the rules. Okay, looking at our next one. Our next one says if we have 6 and it's raised to the power of log base 6 of 13. So see, that's just like log base 6 of 13, but it just so happens to be the power of 6. Well, if you go back and you look at rule number 7, it said if I have a base raised to a log of the same base, this base had to be the same as the base of the log of k, then these things kind of cancel each other out and you're just left with the k. So I'm going to be just left with the k. So that is 13. So that is problem number 8. Okay, let's look at problem number 9. Problem number 9. So one thing you have to remember on problem number 9 is we're dealing with a log, okay, and it's base 2, all right, of x. And so if we just went back and remembered the regular log base of x, we have to go back and remember what it was going to look like. So if you went back and you go back and you use that Desmos calculator that I sent you guys, okay, and you got to practice on those and remember what they look like. Anyway, so we know that graph, the graph of log base b of x, it goes through 1, 0. So it should go through right there, 1, 0. Okay, so it would be like this, goes through 1, 0. But that's not what's happening right here. Because if you can see, we don't go through 1, 0. It actually wants to go through right there. So it's going through like 2 down, right? 2 down. So if it's going through 2 down, go back and remember all that stuff. So remember, if the number is in the parentheses with the x, like x minus 2, if you go back to the parabola function, then that was going to cause a shift either to the left or to the right. And so this was, remember the form is x minus c, and so this is 2, so this would cause a shift to the right too. But this one doesn't shift to the right too. What does it do? It shifts down. So for it to shift down, it was just x. So if you had f at x equals x squared, think about parabola, x squared, to shift it down, you would just subtract 2 off, right? But if you were going to be shifting off to the left or to the right, the x had to be with the number inside the parentheses, and that causes it a right or a left shift. But this one has a downshift, so we just have to subtract 2 from the function. So the function would be log base 2 of x, and then we have to subtract 2 from it. So this would be your answer. If it's in the parentheses, that's going to cause it to shift right and left. Remember, if it's not in the parentheses, it's going to cause it to shift up or down. Oops, sorry. Didn't realize my paper was sideways. Okay? So next one. This is a great problem because it can get you back to your bearings, going back to those graphs. So if you look at this one, it's saying you want to graph these on the same coordinate system. So you have the exponential function, and then you have the log function. The exponential function and the log function. Remember, the exponential function is going to go through 0, 1, just the base one, not adding or subtracting anything to the x or to the function itself. And then the log base 3 of x function, he's going to go through 1, 0, right? 1, 0. So we remember, I mean, I know I showed you guys this picture and we did it in class. It's this one, remember, because these two guys, they have that axis of symmetry, that line y equals x going through the origin, and it's a reflection of the other side, right? If I flip it over, it's the same thing. The exponential function and the log. Okay, so there's that one. Okay, so this next one is a little trickier. You got to use your brain a little bit more. It says find the domain of the logarithmic function, and so I have f at x is equal to natural log 9 minus x. So I'm going to work on this 9 minus x so you can see why the answer is what it is. I like the x to be in front, so I'm going to rewrite it as minus x plus 9. Okay, and then, you know, when we've been talking about these functions, we really haven't had like a minus x plus 9, like a binomial with a negative in front of the x. Now we can have a negative in front of the x. If it's just the x, that we know what to do with, but when it's like this, a little bit more confusing. But what we can do is factor the negative out, and if we factor the negative out, and let's say we take that off, then you know that this means it's going to be shifting, right? It's going to be shifting. And so that's what's happening here. This graph is still going to be shifting, and then this is just going to say it's going to flip, remember? But it's shifting, and it's going to be shifting over where? It's going to be shifting over to the right 9. So your domain, it's going to travel, okay? So it's going to travel all the way out to 9. It's going to travel all the way out to 9. So your domain is going to go, woo, and then it's going to stop right there, right? It's going to travel out to the 9. So the domain for this one would be negative infinity to 9. Okay, so now, once we get down to this number 12, we're really hitting heavy on this page. And we're also thinking about changing anything that we can into an exponent. So look at number 12. I mean, right, that 100 is screaming to me, put me as an exponent. So I'm going to rewrite this as log of 1 over 10 squared. And then I remember I can't really have fractions, and so that's log of 10 to the negative 2. But we know if we have a plain log, his base is 10. And then we know if we use our rule page that if the base and the base are the same, then all we're left with is the power. And so the answer is negative 2. Okay, so that's number 12. Let's look at number 13. Number 13, use a formula. So if we're using the formula, we're just plugging stuff in. This is just a little calculator problem. It says the amplitude, that's the A, is 259. And then it says that the time between waves is 3.1 seconds, and so that's the T. And then it says the B is 2.9, and I mean it's right there. There's the B. Okay, so I'm just plugging this in the calculator. This is not a hard one. So log, and then I have 259 over 3.1, and then add 2.9. So we'll get an approximation. We know that. That's not going to come out pretty. So find your log on your calculator. Okay, so log, parentheses, it's a fraction. 259 over 3.1. Close, toggle out, close the fraction, and then plus 2.9, close out my parentheses. So when I hit log, it automatically gives me a parentheses, and then whenever I hit that fraction, it gave me another parentheses, so I have to close the fraction parentheses, and then I have to close the big parentheses. And so I am going to get approximately 1.936756895, and it says round to 1 decimal place. So to 1 decimal place would be there. And so excuse me, so my answer for number 13, let's see, did I type something wrong in there? Let me try that one more time. Did I get all my stuff? 2.59. Oh, I see what I did wrong. I was not supposed to put that all in parentheses. Let's try that one more time. Like, that's not right. So that's bad. Notice that 1.9 was one of the answer choices, but that's not the answer. Let me try that one more time and get it right in my calculator. I was not supposed to get that double parentheses. So let's try one more time. Log, parentheses. No, don't put parentheses. Fraction. I only need one set of parentheses on this one, so don't make that mistake. Okay, close your parentheses. Now add the 2.9 off the edge. There we go. Now I look right. All right, there we go. 4.8. So approximately 4.82, round to 1 decimal place. So the answer is 4.8. Make sure you get that right in that calculator. I was not supposed to have 2 parentheses. I was only supposed to have the 1 by the log. Okay, next. So here we go again. I see something that's making me think, I need exponents. 1,000 is the same as 10 to the third. Okay, 1,000 is the same as 10 to the third. So this is log of 10 to the third times x, because 1,000x means times. And if we go back and we use our product rule right here, it says break them up and put plus. So that will give me log of 10 to the third plus log of x. And we know that log of 10, remember, this is base 10, so I'm only left with the 3. So 3 plus log of x, and that is your final answer. 3 plus log of x. Okay, our next one says use the properties to expand. So I noticed that I have a quotient, so I know I'm going to use that quotient rule. So I go back and look at my paper. Quotient rule, if I'm using the quotient rule, it says to break them apart and subtract. So this will be the natural log of e to the third minus the natural log of 8. And we do as much as we can. It says expand. We know if we have a power, we pull him up front, right? So 3 natural log e minus natural log 8. And we know that the natural log of e is 1. So this means 3 times 1 minus, natural log 8. So 3 minus natural log 8. And so that would be C. So come back over here and remember, oh, that's not on this paper. Okay, so remember that the natural log of E is equal to 1. That might be something you need to add to your paper. Okay, natural log E is equal to 1. Next. This one says to expand again. So we're trying to expand. I know that if I have a power, I can bring it out front. So that's going to be 6 log base 8 of x. And there's nothing else we can do with that one. So that one's done. 6 log base 8 of x. That's it. Okay. Next page. So I'm on number 17. 17. Expand again, right? Expand again. See another quotient, so I know I'm supposed to break them apart and subtract. So this will be log base 2 of x to the 4th minus log base 2 of y to the 8th. Take your powers, put them out front. So 4 log base 2x minus 8 log base 2y. And then find that in your answer choices. Okay. Next, let's go ahead and rewrite. Remember that square root, we're going to use it a power to the 1/2. So this is the natural log of, now you're going to have to remember a couple things, okay, of x over y to the 1/2. Then we know that using the exponent rule, it says that each of them get the exponent. So this is the natural log x to the 1/2 over y to the 1/2. And then we're going to use the quotient rule right here. So the quotient rule says to subtract. So the natural log x to the 1/2 minus the natural log y to the 1/2. And then we're going to pull our powers out front. So 1/2 natural log x minus 1/2 natural log y. Okay, and that is answer choice D. Okay, next. Use the properties to condense. Okay, so these we were trying to expand. Okay, now you're going to notice this time it's expanded and they want us to squeeze it together. So we're still using the rules, but we're on this side now, okay? So we're expanded, and now they want us to condense. So we're kind of going, I guess, backwards. Okay, so let's look at our first one. We know that if we have a power, right here, 4, then, or excuse me, a number in front, it was the power. So that's going to be, let me write it out. So 4 log base b of m minus log base b of n. So this is going to be the power. So log base b of m to the 4th minus log base b of n. If it was a subtraction right here, that meant it was the quotient rule. Okay. So then I take this guy right here over this guy right here. I make a quotient or a fraction. So that will give me log base b, and then my quotient would be m to the 4th over n. And that is your final answer. And that is B. B. Okay. Next. What are we doing this time? Okay, we are going to condense. Again, condense. That means it's expanded and we're going backwards. Okay, I see a number out front. That tells me it was a power. So this is natural log x plus natural log y to the 9th. And then this is addition, which tells me it was the product rule. So this is natural log, and product rule means to multiply. So I'm taking this times this. So it will be the natural log of x times y to the 9th. And that is your final answer. Okay. Okay, so for this next one, we've got four things. Yeah, 4 things that we're going to be doing. So they want us to condense again. I'm going to use our rules and condense. Okay, so first thing is I see a number out front, which means it was a power. So I'm going to do that first. So I have log base A of Q minus log base A of R plus log base A of P to the third. Okay, so now I'm going to have to go into the parentheses first. So I'm going to go in this parentheses, and it's a subtraction right here, which tells me it was a quotient. Okay, so I would take this over this, divide. So that's going to be log base A, and then I'm going to have of Q over R, right, plus log base A of P to the third. Okay, so if this now is a plus, that means that these two things were multiplied together. This one was the product rule. So then that gives me log base A. So I'm multiplying Q over R times P to the third, which is over 1. So that's going to be Q P to the third over R. Q P to the third over R, and that's D. Okay, so for my next one, it says use common logarithms or natural logarithms in a calculator to evaluate. So for this one, it's not an equation, but they're asking us to evaluate it. So they're asking us to find out what it's equal to. We don't know what it's equal to, so I'm going to say it's equal to x. So if I say that's equal to x, then I can go back and I can use this right here property that we know to be true. All right, remember b to the c is equal to a. B to the c is equal to a. B to the c is equal to a. So if this is true, then b to the c is equal to a. So this is where I am right now. 25 to the x is equal to 386. So it says I can use common logarithms. So if I want to use common logarithms, then I can say the log of 25 raised to the x is equal to the log of 386. And then I know I have a power, so I can bring it out front. So x log of 25 is equal to the log of 386. And remember, my job is to get x by itself, because that's what I'm looking for, right? So I would divide both sides by the log of 25. That gives me x is equal to the log of 386 over the log of 25. So now I can use calculator. So I used my common logarithms in a calculator. Okay. So I need a fraction. And then I need log of 386 over, close parentheses, over log 25, close my parentheses, equals, and so that's approximately 1.850284911. Okay, and so over here, it's right there, it's answer choice A. Answer choice A. Okay, next one, solve the equation by expressing each side as a power of the same base and then equating exponents. Oh, okay, so we did these in class. I know that 4 can be written as an exponent, it's 2 squared. And I know that 64 can be written as an exponent, it's 2 to the 6th. So I'm going to rewrite 4 as 2 squared, but that had a power of 1 plus 2x, equals 64 is 2 to the 6th. So now that I have my bases are the same, then I know that my powers had to be equal. So 2 times 1 plus 2x had to equal 6. Otherwise it wouldn't have worked out. So I'll distribute. So this is a baby equation, like from Algebra 1. And then I'll subtract my 2. And then I'll divide by 4. So x had to be equal to 1. Okay? X had to be equal to 1. So how did I do that? I wrote them as powers or exponential expressions. And the bases were the same. Worked out. Took my exponents, put them equal to each other. Okay. Next. 24. 24. Looks like the same. Yeah, same problem. Okay, so if you don't know this one, you might have had to do a little bit of work on it. I knew that 125 was 5 to the third. I wasn't real sure about 3,125. So what I did was I said, okay, 5 to the first is 5. 5 to the second is 25. 5 to the third is 125. 5 to the fourth, so on my calculator, 5 to the fourth was 625. 5 to the fifth, 5 to the fifth, 3,125. So there he is, 3,125. He is 5 to the fifth. So I'm doing the same thing I did to the last problem. I'm substituting 5 to the fifth in, but it already had a power of x, and then 125 is 5 to the third. The bases are the same, so I know that the exponents had to be equal. So 5x is equal to 3. Divide both sides by 5. So x is equal to 3/5. Okay, same thing for the next one. Same thing because we're doing powers. Oh, remember this guy right here. We don't want e on the bottom. We want e on the top. And so we can write him as e. But remember, how do I get him to move to the top? I make his power negative. So this is e to the x plus 8 equals e to the negative 4. So you know your bases are the same. That means your exponents were equal. Solve your equation. And so x had to be negative 12. Negative 12. Next, solve the exponential equation. Use a calculator. Correct to 2 decimal places for the solution. Okay, so this one doesn't really give me any indication of how to start it. It just says to solve it. And same thing with the next one. When you see powers of 10, like 10 raised to something, and it's this equation right here, an exponential equation, you need to think log, okay, regular log. So I can say log base 10 of x equals log of 419. And I know, remember, 10 leaves me with just the x. So this side equals x. X equals log of 4.19. And so on my calculator, I do log 4.19. And I get approximately 0.6222140023. What they say, 2 decimal places, so it would be 0.62. So that is A. Okay, now this time I don't have a base of 10, I've just got a weird base. So if I've got a weird base, we're going to use natural logs instead of regular logs. Okay, so I'm going to use the natural log. 4 raised to the 8x equals the natural log of 3.2. And then I'm going to use my rule about powers, and I'm going to pull him out front. So 8x natural log 4 equals natural log 3.2. And then I'm going to solve for x, because this is just all multiplied together. So I can get the x by itself using division. So I can divide by the 8 and the natural log 4 to get those to cancel. But remember, when you're solving an equation, whatever you do to one side, you have to do to the other. So that will leave me with x is equal to natural log 3.2 over 8 times the natural log 4. So plug that into our calculator. So natural log 3.2 over, close parentheses, over 8 times natural log 4, close parentheses, hit enter, and I get approximately 0.104879494, 2 decimal places again, and so the answer was 0.10. Okay, 0.10. Next, number 28. So for this one, we're going to use this basic rule because if we look at it, you see the log base and then of A is equal to C. That's this. So then we know B to the C equals A. So B to the C equals A. So 6 to the second equals X plus 2. So 36 equals X plus 2. Subtract 2 from both sides. So X has to be 34. 34. Let's see, for our next one, we have 9 natural log of 6x is equal to 36. Now, we're super tempted because, you know, every time before when we've been working these, we've been saying that we can take that 9 and raise it to a power, but that's not really going to help us on this one. So what we're going to have to do on this one is, let's just get the natural log part by itself first. So that gives us the natural log of 6x is equal to 36 divided by 9, which is 4. So when I looked at that, the 36 and the 9, I was like, oh, I bet I need to go ahead and just divide that because this is multiplied. So then that'll just give me the 4 right there. Okay, that'll just give me the 4. So we know that this natural log, one of our properties says that we can use e when we have this natural log. So simplifying this, we get e to the 4th is equal to 6x. E to the 4th is equal to 6x. And so now we need to get the x by himself, so we divide by 6. And so we get a final answer, x is equal to e to the 4th over 6. So on our calculator, we would get e, there it is, e to the 4th over 6. And that is approximately, oh, we don't even have to go that far. They just wanted us to give the exact answer. Okay, so I didn't have to use my calculator. So they just wanted us to give the exact answer, which would be e to the 4th over 6. Okay. For our next one, we're just going to use that same property right here that we've been using. Okay, this one, because we have a log with the base of something equal to a number log. So we know that b to the c is equal to a, b to the c is equal to a. So b to the c is equal to a. So 5 to the 1st is equal to x squared minus 4x, which says 5 equals x squared minus 4x. Oh, it looks like a quadratic, so that we can solve it. Subtract 5 from both sides. So 0 equals x squared minus 4x minus 5. And then we can factor it. Okay. We know that 5's prime. Don't work too hard on this one. We need a negative 4 in the middle, so the 5 has to be negative. So that tells me x is equal to negative 1 or x is equal to 5. X is equal to negative 1 or x is equal to 5. Now, we have to be careful because we can't take the log of a negative number. So what we have to do is just do a quick check and see, will this x right here make this negative? Because if it makes it negative, I can't take the log of a negative number. So I would plug in, and I can just use my calculator for that, okay? So I've got this x squared minus 4x, which was in parentheses, and I was trying to take the log of 5 of that, right? But so this piece right here can't be negative. So let's test these two numbers that we got. My first number that I think could be good is negative 1. So I'm going to put in negative 1 squared minus 4 times negative 1. So negative 1 squared minus 4 times negative 1. It's positive. So this one's good. Okay, so now let's put in our next one, because remember we can get those extraneous solutions. So let's put in 5. I know that's going to work because 5 squared is 25. So 25 minus 4 times 5, which is 20, and that's 5. So that one works also. So they both work because they don't make this expression negative, because we can't take the log of a negative. Okay, our next one, we got log base 10 of x plus 3 equals 1 minus log base 10 of x. Okay, so let's get our logs on the same side. So we have log base 10 of x plus 3, and then I'm going to add this plus log base 10 of x is equal to 1. Okay, so now I'm going back to the product rule again because I've got the same logs with the same bases, and so I can multiply those together. So the log base 10 of x times x plus 3 is equal to 1. So now I'm going to FOIL that, so, or not FOIL, distribute. Log base 10 x squared plus 3x, right, equal to 1. And so now I know that that will tell me that 10 to the first is equal to x squared plus 3x. So 10 to the first is equal to x squared plus 3x. Subtract 10. I'm solving a quadratic again. So 0 equals x squared plus 3x minus 10. And now I want to factor it, x and x, and 10 times 5 times 2 is 10. I need my 3 to be positive. And so this one's going to give me x is equal to 2. And this one's going to give me x is equal to negative 5. So let's see, are they going to work? So if I put a 2 back in, if I put a 2 back in, this is going to be fine. If I put a 2 right here, that's going to be fine because they're going to be positive. But if I put a negative 5, look, if I put a negative 5 right there, then I'm taking the log of a negative 5. I can't do that. So that means that this negative 5 was an extraneous solution. So the only answer to question number 31 is 2, D. Oh, I forgot to mark the answer for this one. 5 or negative 1. So 30 was A. Okay. So 2 is D. Okay. Oh, we're on the last page. Goodness gracious, this is taking, we're at 48 minutes. Okay, next, number 32. We're in the home stretch. 32. Same thing, solve the logarithmic equation. We're just going to use all the properties that we know, okay? So one of the properties that we know, if we have an addition, then we know that it's the product. These two were multiplied together, right? They were multiplied together. So I get log of 4x equals the log of 5 times x minus 2. So log of 4x equals the log of 5x minus 10. And so this is log base 10, this is log base 10. So that tells us that 4x is equal to 5x minus 10. And then I solve. So I'll subtract 5x from both sides. Negative 1x equals negative 10. Divide by negative 1. So x has to be positive 10. Will a positive 10 be okay in that original? Yep, it doesn't make a negative here and it doesn't make a negative there. So the answer is C. Okay, next. Question number 33. Larry has $2,400 to invest. He needs $3,000 in 11 years. What's the annual rate of return he will need to get in order to accomplish his goal if interest is compounded continuously? You're not given the formula on this one, but I do know the formula because that's the one that I told you at the very beginning. We had to remember that one. The formula is y equals y naught e raised to the RT, where the R is your rate. So this one, it's asking us for the rate. It's saying, what is that R right there? It gave us y. Y is the future value. Remember, what's the future value? It's 3,000 because he needs 3,000. It gave us y naught because that's what we started with. He started with 2,400. And then our t is 11. So we can actually write an equation. So our equation says 3,000 equals 2,400 e raised to the R, that's what we don't know, times 11. So I'm going to divide both sides by 2,400. So that gives me 30 over 24, because those zeros cancel out. But I can simplify 30 over 24. 30 over 24 is 5 over 4. Okay? So I get 5 over 4 is equal to e to the 11r. So now I can take the natural log of both sides. So the natural log of 5 over 4 equals the natural log of e to the 11r. And now I know that the natural log of e is 1, right? And so that just tells me that I can divide right here by 11, because if the natural log of e is 1, so let's see, I'll write it right here. So we get the natural log of 5 over 4 is equal to 11r. Divide both sides by 11. So r is equal to the natural log of 5 over 4 divided by 11. So if you take your calculator and you get your fraction, get your natural log, and your natural log, you need a fraction right there, and it's 5 over 4, close your parentheses, go down, divided by 11, hit enter, you get r is equal to, let me put this off to the side, r is equal to 0.02028. Okay, now you want a percent, so you got to move the decimal point 2 places. So moving it 2 places to the right, that gives you 2.028%, and it says to round it, so that's 2.03%. So the answer is A. Okay, next. Okay, so for the next one, you don't even have to work real hard on that one either. You're given your formula. You're told that the current population is 192, so that's your y naught. You're told that it is 7 years, that's your t. I mean, everything's in there. So we get y equals 192 e raised to the 0.043 times 7, and so you should get 259.432, and so the answer was 259. The next one, there was no math at all. They just wanted to see if you noticed. Like, did you notice that the percent, the rates right here were right there? That's your rate. Like over here, well, on that first one that we did. So if I'm looking at this one, this is my rate right there. That's my rate. So my rate is, move the decimal point 2 places, 6.7%. It was just asking for the rate. There wasn't any math on that one. And then our last one, I had to look this formula up because I did not know the formula, but I found this formula for half-life, and I suppose that Mr. Davis has already given you the formula. So my formula says n of t is equal to n naught, which means that's the starting rate, times 1/2 raised to the time divided by the half-life. So reading my problem, I got my n naught was equal to 40 because it says it has 40 grams now. My b was equal to 710 because that's my half-life. So that's my b. Oh, the formula had a b and a t. So it had b and t in it. But this is just your half-life right there. Okay, half-life. Sorry. It had t divided by b. And then my time, they already told me my time. My time was 900 years. He says how many will be present in 900 years. So I get n at t is equal to 40 times 1/2 raised to the 900 divided by 710, because that's my half-life. And then if I plug all that in the calculator, I get n at t, it's approximately 16.6139. And so the answer was A. Now you'll probably need that formula, but that's what I found.